Hello, I'm here to make a video that explains, maybe in my own words, what it means to study the composition of two functions. So I wanted to just kind of do this on my notebook here and talk about just the definition, what it means to compose two functions. So unlike the adding, subtract, multiplying, and dividing, where you just take the two functions and add them together or subtract the results or whatever the operating symbol says, composition kind of has a certain order to it. And it means you start with one function and you take the output from one function and you use it as input to another function. So I kind of have a flow chart here. So this is just the original number that you're dealing with, and you plug it into the g of x function. Of course, we call the output to that g of x. That output is going to then get plugged into f of x. So instead of the x, we have the g of x in here as the input. And so that's what composition looks like. The f function is being composed with the g of x input or ingredients kind of. And this is the notation that we use for this. We do the little open circle, and it's always the function's name that's nearest to the input that you do first. And that becomes input. And then the outer function, the one that's done last, is the one that's farthest away from the input symbol. Okay, so it's probably easier to understand with numbers than it is with letters. So I know I have the general case up here with the letters, but I wanted to start down here with, or I have f composed with g of 1, and I'm going to copy the functions down here so I don't have to look at the whole thing at the same time. So f of x is 3x minus 1, and I have g of x being 4 times x squared. All right, so you can ask for these compositions in either order and it will give you a different answer. So you have to pay attention to which order that they're listed in. This says g of 1 will be composed first. And once we figure out what g of 1 is, we'll put that answer into f of x. So it kind of goes like this. All right, so let's figure out what g of 1 is. I'm going to do it separately. So g of 1 would be 4 times 1 squared, which is just 4. Okay, so that's going to go into f of x. So we'll put 4 into f of x. That's 3 times 4 minus 1, which would be 11. Ran out of room there. All right, so 1 got plugged into g of x, and the number 4 came out. So that was 4, and then 4 went into f of x. F of 4 was 11. Okay, so f of g of 1 is 11. Okay, notice we have the order flipped around here, and now I'm doing 0 as the input, but I'm going to put it into f of x first. So this is doing f of 0, and when I figure out what that is, I'm going to plug it into g of x. All right, so I'm going to just, over here to the side, just calculate f of 0, which is going to be 1 or minus 1. All right, so f of 0 is really negative 1. That's going to go into g of x. And then I'm going to work out g of x, where negative 1 is replacing the x, and that's going to give me 4. So that means g composed with f of 0 is 4. Okay, so it's about the order. You start with the input, you kind of work right to left. The input goes into the first function, the answer to that one goes into the next function. And what comes out at the end is your composition. You know, and you can have multiple functions involved. You can kind of daisy chain these things together and have something like f composed with g composed with h of a number, and you just kind of work your way out. Okay, so that's what it means to compose two functions together when there's a number here is the input. Okay, now the more theoretical kind of general case would be when it doesn't have a number here, it has an x here. So this means we want another expression in terms of x that represents the two of these things combined together. Okay, and one of the things that we have to be careful of in word problems is that we have to make sure the inputs and output units kind of match up. So whatever the g of x output unit is, that needs to match up with what the input unit needs for f of x. So the output here has to match the input here for us to be able to place it properly. But this is just a general case with no applications involved. So this means g of x is going to be the input to f of x. It means the entire expression. So I'm going to just write the actual, here's the inside part, g of x. That's going to be place as input to f of x. Well, g of x, I'm going to replace that with the actual expression. It says g of x is 4x squared. So I'm going to replace the function notation with the actual expression 4x squared. And then I'm just going to work out the f of x function where I replace x with 4x squared. So instead of 3 times x, it'll be 3 times 4x squared, and then minus 1. And we usually simplify it a little bit, so that would give me 12x squared minus 1. Okay, so where the x is here, the entire g of x function replaced it right there. Okay, that's what happened. And the direction it's going is because the g of x was the inside one that was written right next to the x. So that's the one that's used as input to the other function. Okay, so if you have a composition notation here and there's an x, if x is going in as the input, you're most likely going to have an expression with x in it as the output. Whereas down here, if you have the input is a specific number, a value, then you're going to have a specific number as your output. Okay, so let's do one more. We'll do g composed with f of x. So I've kind of flipped it around because it won't be the same. It's not like addition or multiplication where it's commutative and it doesn't really matter what the order is. This order is very important. So this says we're going to take f of x, it's the inside one. And when we figure out how to replace that into the x for g of x, we'll have our answer. All right, so this time we're starting with f of x. Now f of x is 3x minus 1. So instead of writing f of x in here, I'm going to replace it with the actual expression. And that's what I'm going to use in place of the x over here. So g of x says square it and then not times it by 4. So square it, times it by 4, and we'll replace the x with the entire other function. So in this case, the f of x is being dropped in where the x is right there. All right, I'm not going to bother to simplify that out because I don't know that they'll have you simplify things like that when it gets to be, multiple steps like that. But that's just a basic idea for composition, is the one that's right next to the x is the interior function, and it is used as input to the next one out. And then you may need to simplify it if you have x's in it. If it's numbers, you just keep working until you have one final number. So you'll start with the number that's the input, plug it into the function right next to it, get the answer, -1. And then you'll take -1 and plug it in the outer function and work out that answer. And you're done. When you get to the front of the number of the function names, you're finished. Okay, so that's composition of functions. I hope that helps. Let me go ahead and close this down so I can get it shared.